Alright, I'm just starting the live. I'm audible, okay, right? Is that good? Or should I use the mic? Okay. Sure. Okay. Yeah, it's recorded on YouTube. Yes.
Don't be shy. No.
Why should we get started? Okay. So thanks everyone for joining. My name is Chakradhar Jonagam. I work as a OpenShift specialist in Red Hat. My day-to-day job is going to customers, helping them understand OpenShift or containers in general, doing deep dives, POCs, mostly with like different customers all over North America. That's what I do. I'm also a CNCF ambassador. It's a part of Cloud Native. It's part of Linux Foundation. It's called Cloud Native Compute Foundation, which I think you are very familiar. They are very active in Seattle. So this talk is about microservices and Istio with OpenShift on Azure. So it's a very big title. But the point here is we are going to see some microservices on OpenShift, which is running on Azure. That's the whole point. Okay. So different layers for different purposes. So let's jump into it. So who here knows OpenShift? Like, okay, a bit. All right. And then who here knows Kubernetes? All right. Okay. And I want to see if I want to touch the basics or skip directly to OpenShift part. So are you all familiar with containers in general? Like what's a container is? Okay. So I'm gonna skip the containers part just to level set everyone why we need containers sort of thing, but I'll not spend too much time on it. Okay. Uh, we might be very familiar with this. It works on my machine, right? This is a usual conversation between developers and operations in the day-to-day life. Uh, this is happening because of this. You have different environments for different levels of your application. In dev, you might have Windows. In QA, you might have something else, and then production, you might have something else. And the versions might be different. The environment completely might be different, or somewhat different between these dev, QA, and prod. So there's a good chance that things will fail when you move your application from dev to QA and QA to prod. So to avoid that, what we want to do is, what if we can package operating system, middleware, application all together as one single immutable image? That's what is all Docker and containers are all about. So let's skip it. I hope this is a very familiar concept. So this is addressed by Docker image. The packaging system of Docker will address this issue. Then what are containers? So when you want to run these binaries, you run them as containers, right? So what are these containers then? So Jesse, I've stolen it from Jesse Frizzle. I liked it very much, so I stole it. So it's that you have a server, and every server has a process, and these processes can be isolated using Linux fundamental tools like secomp and cgroups. So such that each of these processes can think of itself as its own VM, but at the operating system level, it is just a Linux process. Okay, from the developer point of view or from the deployment point of view, you might think it as a full-blown VM, but under the hood, it is just a process. What's the advantage with this? You get a larger density per hardware that you have when compared to the mode that we are using now. Like maybe you're using VMware um, for isolating your apps, but those extra OS thing can be avoided if you use a container instead of a full-blown VM. So you get larger density per hardware. And then when you deploy applications on Kubernetes or OpenShift, you get something like this instead of the very different versions and different environment with the way that we do now. So this would be the final deployment trust type. So when you want to run these containers at scale, you would need something like a Kubernetes, like a container orchestrator, to run them across multiple nodes. Because running a single container on my laptop is fun, but when you want to scale it, you have to think about networking, storage, security, a lot of things you need to handle. All right. So Kubernetes handles that very, very well. So that's why we need some kind of container orchestration tool. Then we talked about Kubernetes and why exactly is OpenShift, right? So this is what I see as OpenShift. OpenShift origin or OpenShift in general is a combination of Kubernetes plus all the missing development tools that are not there in Kubernetes. Kubernetes is built for providing that fundamental distributed system for your applications so that you can uh, deploy them like in a robust fashion. So if something goes wrong, Kubernetes will take care of it. But it is not designed for development activities, right? Which is very much a need for enterprises. Enterprises need a way to deploy these applications. They don't want to spend time building on tooling around Kubernetes to make it enterprise ready. So OpenShift is a enterprise ready Kubernetes, right? But under the hood, it is a Kubernetes, so you can use all the features of Kubernetes plus all the developer features. Okay, so you get Kubernetes goodness and then also all the missing developer features. Also some other awesome features. I'm going to show it in a bit, but think of it as Kubernetes plus all the missing tools and then some other add-ons. We always use this latest Kubernetes code, so you can literally execute kubectl commands on OpenShift cluster. Okay, and then this is how I think of Kubernetes and OpenShift. Kubernetes acts as a kernel for your data center, so you no longer worry about individual machines. You just need the enough capacity for your applications. Even if some node goes out, you still have your applications up and running safely. So you don't need to go like in the middle of night. You don't need to fix it. You can go later in the morning and then go take a look. All right. So that piece is taken care by Kubernetes very efficiently. So this is how I think of Kubernetes and OpenShift. Kubernetes acts as a kernel for your entire data center, whereas OpenShift is like an operating system for your data center. With just kernel, you'll not be able to deploy applications. You need some kind of a ready-to-use thing that is OpenShift. Okay, that's just an analogy. This is another analogy I have. Like, what is Docker? It's basically a container runtime and packaging. What is Kubernetes is basically a container orchestrator. Like, if you want to run containers across thousands of nodes, you need Kubernetes kind of orchestrator. And OpenShift is basically have taking care of that as well. Okay, so when I say Kubernetes and then OpenShift, it doesn't mean you have two things running. These are actually combined in one thing. So OpenShift is enterprise-ready Kubernetes, and it's like an operating system for your entire data center. And then we are also going to discuss today about Istio, which is a service mesh. I'm going to explain what service mesh is in a bit. But understand that you need a some kind of control plane to be able to see what is going on inside your applications once you deploy them. So it's like your day two operations. Once you deploy the applications, you need to have visibility across your applications, and then also dynamically change your routing rules, extra, introduce new versions. All those things you need some kind of a control plane to look after, right? So that is provided by Istio. I'm going to discuss more in detail in a few seconds. So that's for the day two operations of your applications. And then the most important feature of OpenShift is if you want to start with just Kubernetes or Docker or any other orchestration tools, you need to start only from Docker image. So you need to build your tooling to be able to convert your source code into a Docker image to be able to deploy on your orchestration tool, right? But whereas in OpenShift, you can literally start from anywhere. You can start from Docker image. If someone else has already done Docker image, they can start straight away use Docker image. You can also start from Dockerfile. Like you say, this is where my Dockerfile is. Just go and create an image and then deploy. OpenShift can do that. You can also start from source code. Like let's say you are adopting your enterprise is adopting container technology. Not everyone is aware of how to write a Docker file, efficient Docker file, right? So for those folks who are just starting with containers, they don't need to worry about what is going on inside OpenShift or Kubernetes. They just focus on source code. So OpenShift can directly convert your source code into a Docker image. We will see that in a minute. Okay, that's the third feature. And then the fourth feature is like if you have already made some investment in generating WAR files or jar files, you can start from there as well. Okay, so you can literally start from anywhere. You're going to see it in live, as a demo. So I have an OpenShift cluster running on Azure. You can see here, this is a single node cluster, but I can pretty easily have a good amount of nodes added to this cluster. So as a OpenShift administrator, let's say I'm a OpenShift administrator, I want to start let my developers use the OpenShift cluster. So how do I do that? So I'm going to create different namespaces or projects for each team, and then each team has access to only those namespaces. So if you think of recent Kubernetes features like multi-tenancy and everything, these were there in OpenShift from long time. This is like a truly multi-tenant system. So your different teams have are scope to only those projects which they have access to. They don't mess with the other projects. Okay. So as a cluster administrator, I'm going to create teams like, let's say, a dev team and a QA team, and maybe a operations team, which is CI/CD team. Okay, so just imagine that you have different teams. So as a developer, I go into my namespace. So only this is accessible to me, and then you can control how much CPU memory is allocated for this team. Okay, so I came in here, and then I can start deploying applications onto this. I can use UI or from CLI. Both ways it works. I'm going to show it from CLI, but assume that most of the things that I'm doing on CLI can be done on UI as well. One thing that you miss on Kubernetes is Kubernetes has a very basic UI, but OpenShift has a very extensive UI. Like about I would say 50 to 60% of features that you support on CLI are on UI. Okay, that's the level of integration we have. So as a developer, what I want to do is deploy applications onto OpenShift in different ways. So let's start with source code or like anywhere from here. Okay, so I'm going to show the four ways. I've scripted this, but this is all happening live. I'm not showing any replay of anything. Okay, so I have a Node.js application here. Pretty standard Node.js application. I haven't done anything specific to OpenShift. It has a dependencies file and then a API spec file, which says like when I hit this endpoint, it says hello and everything. Okay, so standard Node.js file. So as a developer, how do I deploy this application onto OpenShift? So let's take a look at that. I just say OC new app, and then give my name called Node.js, and the version I want to use is 6 Node.js 6, and then give my source code address. That's all I do. I did not write any Docker file. I did not write any or create any Docker image. Nothing else. I just said where is my source code and what base image I need to use. Okay, and then you can see that within few seconds, a build will be triggered. Okay, sorry, I'm in the wrong namespace. I'm going to switch to my project. Otherwise, oh, sorry. Dev, because I'm doing it in dev, I want to show it in dev. So just open that and then say OC new app and then give the source code and the base image which I want to use. Now you can see a build got triggered here. If you look at the logs, it is cloning the source code. It reads the package.json dependency file. It does the install, converts everything into Docker image, pushes into the internal registry. Everything happens automatically for you. You don't need to any of this. If you want to build a tooling around Kubernetes to do all these pieces, it will take years. Trust me, because there are a lot of things that you need to take care. Right. So you can see log. It is completed now, and then you can also see that it converted everything into a Docker image and then pushed into the Docker registry, right? You can also see the logs from the CLI. Okay. So within few seconds, within a minute or so, I was able to deploy my application, and then I also get a route out of the box. So I just hit create on this route, and then I get a route for this application. Like click on this, and they can see my application is up and running. Right. So think of doing this with just a Docker container or Kubernetes cluster. It's a lot of hard work. And then I'm going to show you how to deploy with Docker image. So you can see this is my Docker image, which is on docker.io, and in my namespace. This is my Docker image name, and then I say OC new app, point to that Docker Hub image name, and then give it a name. That's all. Right? So it goes, it fetches that image and then deploys it onto my OpenShift cluster. Everything is done. And then if you have a authenticated registry, it also has facilities to provide your Docker CFG file to be able to pull the like have those secrets to be able to pull from the authenticated registry. So all these enterprise needed features are in there already, right? So you can see my Docker image got deployed now. This is from source code, and this is from Docker image directly. I can also hit create a route and then access it. Okay, so I was able to access this as well. Okay, so we have seen source code, and then we have seen from Docker image. Let's go into the next one. This is from dockerfile. So I have a Docker like repository which has dockerfile in it. You can see that this is basically building a from CentOS base image. It is installing Java and Maven. That's it. Okay. So I want some image which has CentOS, Java, and Maven installed on it. So how do I tell OpenShift to do this build or do this build based on this Docker file? All I need to do is put this strategy equal to Docker flag here. Only that's the only thing that changes. You just say strategy equal to Docker, and now it understands that I need to read the Docker file and then do a build. Okay. Now, if I take a look in the build logs, stop me if you have any questions. I'm going fast, but this is the easy stuff. So you can see it read it cloned the repository, it read the Docker file, it has done all the Docker build, right, and then converted everything into Docker image and pushed into the internal registry, and then also deploy it in a second. Okay, so all these are done with one command, right? Now deploying it from a jar file or a war file. Let's see that. I have a jar file inside binary this directory, and then the specific format it needs to have is just have a folder called deployments and put your jar file inside that folder, and then OpenShift will understand that I need to create an image which with this jar file, and then that Docker image will be ready for ready for launch. Okay, so the command for doing it is oc new build, and then this time say dash dash binary equal to true, and then it understands that I need to build it from jar file, not from source code or not from Docker file. It's pretty easy. Okay. Now, if you take a look in the build process here, you can see this build process will happen once I upload the jar. This is only for specifying the metadata. Once I have that, I'm going to say OC start build and build it from the current directory. Okay, and then it uploads the jar file inside the base image that you have already have, and then creates a Docker image out of it. So now it is done. You can start deploying your app just like that. Just say OC new app, and then give the image name that you already have. It's doing the build, still doing the build, so it is throwing the error. So you can see it is still doing receiving that. So it's converting everything into Docker image, and then push is complete. Now all you need to do is go deploy that. You can also deploy it from UI, like I said. Just go to the namespace, that is you are in dev namespace, and the image name is my fatjar app, and then take the tag that you want, give it a name, maybe my app one or something like that. You can also provide different environment variables, labels, everything inside this UI, and then hit create. Now you can see my application is getting deployed. Is it making sense, or am I too fast in this? Let me know if you have any questions. Yeah.
So right now, all four of those are in the individual repository, as well as some of them. Right?
Yes, these are all version controlled inside the OpenShift registry. Just like you version control your jar files or war file in Nexus, in the same way you can also version control everything inside your registry of OpenShift. Okay. And the good thing is, build only happens in dev. When it moves to QA or production, only the whole binary goes across your environment. So there is no rebuild process. So with that, you get more predictability of your application working across different environments. Whereas now there's a good chance that things will fail across environments, but when you have all these things combined together, there's a very good chance that it will work. Okay, and then create a route, and then you can see my app is working now, right? So we have seen all these four ways. Here, if you're using the standard any other orchestrator, you would only do this or this. But if you want real adoption, you would need source code to, like, not everyone is a Docker geek, right? You have some people who wants just to code. So this is a real game changer for container adoption, and also this is a pretty big one, right? So different ways for deploying your application. Any questions on that?
Quick question on the pipeline. Is that fixed to
Yeah, 6.2cz. Small z. So I have my applications up and running in dev. Developer is happy. Now I want to move this application to QA and then up to production. Let's assume that. Okay. So how easy is that? Let's take a look. Developer said this welcome app is ready for testing. So QA comes in now, and then let's go to QA. Click on Add to Project. Click on Deploy Image, and then select the namespace that dev told that it is good. So dev is in this namespace, and the developer wanted me to test this application, which is welcome application. Okay, and he or she might give a separate tag, or by default it goes with latest, and then you can go hit create. You have your application up and running within few seconds in QA. So think of doing it in a traditional way. How long does it take for your application to move from dev to QA? This happens in minutes or seconds, right? So that's the power of having a container-based orchestration tool, right? So it is now pulling the image, and then it will deploy onto OpenShift. So you can see if did I do anything wrong? Maybe I did not provide the permission. Okay, give me 1 second. Say dev. Yeah, I did not provide the permission. So when I say welcome and then latest, I need to give this permission because these are isolated projects. Dev should provide QA to be able to pull their artifacts from that. Okay, so I'm gonna just execute this. Now it should be able to deploy. So give it a couple of seconds. It will be able to pull it, or I can just go click on this, and it will start retry again immediately. Yeah, I can see it is up and running now. I can create a route which is specific to QA. This is not dev URL. I can hit this, and then you can see it is up and running. Okay. So from dev to QA, we have done it in like a minute, right? So when the QA is happy, it can go to production in the same way. It again happens pretty quickly. This is a manual way of moving your application from dev to QA. But what if you want to automate this using maybe a Jenkins or some automation tool? Okay, so let's take a look at that. Now QA is happy, or the application is ready, or you want to set up a automation process for this. So you approach the operations folks, and then operations needs to set up a automation process for this particular application migration from dev to QA and QA to prod. So how easy it is, let's take a look. You just click on this import YAML JSON here, right? And then you import a simple pipeline file which looks like this. Let me do a zoom. So this is all you need to care. You can define your own stages. In this stage, I'm doing a build in development, or you can have your own stage. In this stage, I'm deploying it in development. Maybe I'll do some testing, whether like integration testing, whether everything is working or not. This is all Groovy code. This is not specific to OpenShift or anything like that. And then you can have your own stage like deploy to QA or deploy to production. Okay, but before deploying it to QA, just ask for permission, like approval permission, like manual permission. So as simple as that, you just copy this entire thing and then import into your CI/CD namespace. That's it. Your pipeline is ready. Okay. And then click on the pipeline, select your pipeline, and then click on start here. And then that will show you the entire automation process in this UI, but everything is really happening inside your Jenkins. Sorry. This actually needs a Jenkins instance to be deployed. Until then, it will not be able to start it. Let me go and, okay, this already started. So it is now pulling the Jenkins image. it will deploy the Jenkins instance and then run the pipeline. Okay, so give it a few seconds, and it should be able to start the pipeline. It's now checking whether the application is ready or not. That's a very common thing. So it failed because Jenkins is not ready. Now I'm gonna kick off this. Okay. Oh, okay. So we did one more. We need to do one more thing, which is I've deployed it in Jenkins. Jenkins, this CI/CD namespace is trying to pull images from dev and then from QA, like doing all the automation process. But we haven't given permissions for this team to be able to pull from dev and QA. Okay, the same step that we missed for the QA process. And then that process is again a couple of lines. So I just say like this, which means uh, Jenkins instance, which is running in the CI/CD namespace, has access to QA. Jenkins instance, which is running in CI/CD namespace, has access to dev. Okay, pretty simple one. I just execute these things here, and then now it should be able to pull the image from here. Okay, go back here, and then they say start pipeline. Now it should be able to do it. I can see it is working now because I provide the permissions. Okay, so you can do pretty much any automation in this Jenkins build pipeline, and everything happens within that pipeline spec that you give. Okay, if you really want to see what is happening, like what Jenkins is doing behind the scenes, you can just click on this view log, and then log into the Jenkins instance. Come on. So you can see it is real Jenkins. Okay, we just talk to Jenkins instance over API and then get all the details. But everything is happening inside Jenkins. So whatever automation that you can do inside your Jenkins, you can also do it inside OpenShift pipelines. So you have a very big, very high-end customizations that you can do. And now it is deploying in dev. Mm-hmm. Yeah. Jenkins is also running as a container. So there is a master Jenkins container and there is a slave Jenkins container which comes up, does the job, and then it vanishes. So you also save on resources. You won't really waste on a full-blown Jenkins cluster. So when you say YAML, like if you look at the YAML file, it has a spec called Jenkins, like build config, like type equal to Jenkins file pipeline. When you have this, it understands that I need to do this over a Jenkins instance, and then it does all the job. Okay, so that's the key. So now you can see it deployed in development. It scaled to do probably 5 instances because we said 5 instances. So you can see we said it is 5 instances. So if you go to your dev instance, you can see it already scaled to 5. I did not scale it up. It automatically scaled because you mentioned in the pipeline. And then it is asking permission to deploy into QA because we mentioned that permission thing, right? And then when you hit proceed, it will go and deploy it in QA.
Now, that was waiting on the Jenkins pipeline.
Yeah.
Now, what happens if you kill your Jenkins container? I mean, I'm kind of looking at Docker containers as being the same thing. So if you restart it, generally the data is thrown away.
Mm-hmm.
I would think, though, that with this, obviously, if you kill that container, dies or whatever.
Yeah.
If you want that pipeline to resume where it left off, how does that work?
So in OpenShift, you can back up you can back any container with a storage. Okay, so I'm going to show it in using Azure Disk, like Azure file system, how you can back up any container with a permanent storage. So even if your container goes and comes back up, you still have your storage.
So it's going to be
Yes. Yep.
What happens if you want to reset that instance? You've got somebody else that will have to go back and make some changes in Jenkins that aren't driven by OpenShift. Is there a way to kind of push button and reset that?
So most of these pipelines are version controlled. Okay. Like you mentioned the pipeline, and then that happens internally inside Jenkins, right? So these pipelines, you can version control them. And then if you want to roll back to a previous version, it's pretty easy. You have a history, and then you click a button like roll back, and then it goes back to that particular version. Let me show that.
Does each active pipeline get its own Jenkins?
You can do it. You can have each of your team have their own Jenkins instance up and running. You don't need to share. Yes, actual master. Yeah. That's the new trend I've seen. It used to be like one cluster shared by all the teams, but in this scenario, it's just a container. It's just a process. So you actually do it.
Okay, I need this developer tool. I have one started out populated with
Yep.
after whatever storage.
This is a pipeline that's solely for the purpose of promotion in the environment.
Not really. I mean, in this case, it is just for the promotion, but you can also have like SonarQube, code quality analysis. Maybe you want to analyze for security vulnerabilities. A lot of things that you can do inside that pipeline. Just for the sake of simplicity, I've shown that, but it's you can go as much as you can think of with the Jenkins.
It's got a feature called pipeline, that is basically putting a pipeline together, call this, call that, call that, call that, and you have approvals, whatever intermediate steps you want. That kind of the tail end of that. I'm sorry, you said it was Groovy.
It's a Groovy syntax, and it's called specifically called Jenkins 2.0 syntax. But it's a, whatever you can do it in Groovy, you can do it there. That's the whole point.
So the tail end of that thing that actually has the pipeline.
Yeah, this one. And most of these integrations you don't have out of the box. Like let's say if you want to do it with just with Kubernetes, you have to do all these things hand code, like do these integrations on your own, which is a quite big investment. I would say it takes so it takes a quite good amount of time as well.
So that's where you're more likely to have an external kind of a single enterprise-wide Jenkins instance, or at least more centralized Jenkins instances that drive OpenShift, whereas this is really reversing that. Driving Jenkins to using the same features.
Yeah, you can actually integrate with the external Jenkins as well. Like let's say you have already made a big investment in.
But you have a choice.
Yep.
Whereas if you go ahead and just have a box, you don't get that.
You can, yeah, you can get it, but it takes good amount of time and research for you to do that. This comes out of the box. Is not the GUI as well. Like this GUI is custom built for talking to Jenkins. Right. So that's the CI/CD pipeline. Let's say this is your day one operations. Everyone is happy, but you want to introduce new versions now, right? So how do you do that? OpenShift has triggers, like you can integrate. You can have every build that you see here will have a GitHub webhook generator. So you can just put this GitHub webhook inside your source control, and whenever you have a push, this automatically gets kicked off. All right. So that automation also you can put in. Any questions on the deployment side? So we'll see the storage part now. So I have a Azure cluster. This is actually running on Azure, and then I have a storage like Azure file. You can also use Azure disk, but in this case, I'm using Azure file. Yeah, I created Azure file called example1, right? This I want to use as a storage for my containers, okay? So in this case, there is a single node cluster, OpenShift cluster, but in reality, you have, let's say, 1,000 node cluster, right? Your container might come on one node, and then after some time, it might go on a different node. But how do you maintain your data? From a developer point of view, I don't care where it is running. I just want to have a storage at this location for my application. That's it. Okay. So how do you want to achieve that if you are using containers? So so I can do it like right now. This is a cluster from scratch. I didn't do any pre-setup, right? So what I need to do is I need to get this storage one. The only thing that I've added here is, let me show you a secret. So this is my secret. Don't even if you take this, I'm going to delete it later. But so yeah, you just import a secret which says my Azure account key and then Azure account name. So it can go and talk to Azure and then get the storage. Okay. Once you have the secret, all you need to do is just create a persistent volume. So you can see this is from the scratch. I didn't do any pre-setup. So in the persistent volume, I say I need 5 gigabytes. So this volume is of size 5 gigabytes. And then I want to have a access mode called read write many. So multiple process can read and write from the same location. And then to be able to create this volume from the Azure file system, it needs to know the secret. Okay, that is what I provided here. And the name of the share is example one, which you have already seen. And then read only is false, obviously. Okay. Okay, there is one already existing. I'm gonna just name it as AZ Azure disk or something like one. Okay, this is not really a Azure disk. This is just a Azure file here. Okay, now that I have PV, that PV can be attached to any of these applications. Okay, so let's say I want a storage on this particular container. I just click on this, click on configuration, add storage, create storage. I have multiple options here. I'm going to show you in a minute. So this storage is for my welcome application. So my welcome app storage. Maybe this is a MySQL storage as well. Okay, it doesn't really count. So this I need in a read write multiple mode. You can mount it in different modes, like only read only, like single process, multiple process, like that. Okay, multi process. This should match the size of the request should either match the existing one, or it should be less than that. Okay, but in reality you can have dynamic provisioning where when you say 5 gig, it will go and fetch a 5 gig. Okay, and then hit create. So I have my storage here, but I want to mount this storage at a specific location for my application. Let's say at a location called data inside my application, right? And then hit add. That's all you need. So from literally zero with respect to storage, we are able to mount it like right away. So you can see a new deployment is happening. It is basically moving from the old deployment to a new deployment where is that it has storage in it. Okay, so you can see it is slowly taking now the old one, bringing up the new one, taking up the old one, and bringing up the new one. Right, it's in a rolling deployment fashion. Now, if I don't want to wait, just click on any running instance, go to terminal, ls data. So you can see that data is there. That Azure disk already has a text file called hello.txt. So that is showing here. But if you don't want to believe me, you can create another one, hola, something like that. Right, and then what I want to do is scale these containers to 0. That is when you say your container storage will be gone, right? So it's like 0 means nothing is running there. Now, if I scale up back to 1 or maybe 5, I should have that whatever I stored in there. Okay, so this time this container might be running on node 1. When I scale it up, this might be running on some other nodes, maybe 100th node or 1000th node. So the unmount and mount happens automatically for you. All right. So from a developer point of view, I always have a storage at that particular location. That's all I need to keep. All right. So this is like abstracting your applications from your underlying infrastructure. So cat, I mounted a data, and then okay, sorry, cd. Really? Okay. Did I create it? Okay, and then data. I have two of them. I'm gonna scale it down to 0. Oh, okay. Yeah, right. I don't know. Maybe let's give it a try. Because I tested this multiple times, it works fine.
No, that's right.
So terminal, go to see data, and then you see two files there, right? So yeah, you're right. I think I created in home folder. I was not in the right one. So that what this means is you can not only run your microservice application, you can also run your non like microservice applications, maybe legacy applications, right? So this is which is a very big feature for any enterprise, like moving from traditional legacy applications to maybe cloud native applications, right? So that's a very big win there for enterprises. So this is all I have on the application day one operations, like deploying applications, maybe scaling them a bit, something like that. Yeah.
So, okay, great. This is fine for non-persistent storage. What if you make sense in terms of what you have to do about persistent, writing to persistent storage?
This is persistent storage.
It is persistent.
Yes, this is persistent on the Azure file system. Yeah. So you can use a lot of file systems. In this case, we are using Azure file system. Yep. If you don't attach any storage, these are all ephemeral. Once you scale down, everything goes. But you can see it retained, right? So the second thing I want to show is the day two operations. Like once you have your applications up and running, maybe you want to introduce new instances, like new versions of your applications. But when you are dealing with microservices, because you have a lot of problems when you move into a microservice-based deployment. So a few of them I listed here. I have done a deployment based on microservices. I would say the experience is not so good. Because the primary reason was we don't have a better visibility into any of the microservice deployments. Like if something goes wrong at some place, we don't know where things went wrong, right? That's my real experience, but this is mostly from the books. So distributed tracing, you need some kind of tracing to be able to trace your request, like from your origin, when microservices are calling other microservices, how do you trace that request, all right? And then you need some kind of distributed tracing. As of now, you have to use some kind of libraries like Zipkin libraries specific to languages, like let's say if it is Java, you have a lot of Spring-based libraries to be able to do this discovery piece. But if you switch from one microservice to like one language to another language, you have to build your own, right? For Java, it is there, but if you are trying Node.js, then you are on your own, right? So think of that. And then there is a service discovery part, right? Like when you scale your application, your load balancer should be able to detect all the instances of your application and then add them into the whole load balancer rules. Okay, when something goes wrong with one instance, your load balance should go and then remove it, right? So the service discovery part, and then taking care of the health of those instances, removing them whenever they're not healthy, and then so when it comes to containers, service discovery is very critical, right? Because things will move here and there pretty easily. And then you need something like retries, right? Like let's say uh, your service A is calling service B. If for some reason service B fails, that service might affect the other services calling this, right? So you might want to have some kind of technology, like maybe a specification that try 3 times. If it doesn't work, then go and fail, right? So that kind of things. And then load balancing we already discussed, like, and also securing connections, right? If in between microservices, how do you secure your communications? Most of the times, at least in my knowledge, in my deployment, all the microservices inside the cluster were open to each other. Of course, they have like user level authentication, but at let's say layer 4, they are unable to talk to each other without any problems. And also, you need some kind of metrics. Let's say microservice A is calling B. How many times? How many times this is failing? How many times how much time it is elapsing for this communication? All those kinds of metrics. All right. For this, you need to have libraries like Netflix Atlas embedded into your application. Right. The whole point here is to achieve all these things, you need to build libraries. You need to embed those libraries inside your application, and then when the language of your library changes, then you have to build your own, right? So a lot of effort goes into getting all this done in your microservice. So the primary point is like, what if you can get all of these without writing any code? That's the thing that we are going to discuss. Okay, without writing a single line of code or maybe 1 or 2 lines, how do you get this? Okay, so that's what Istio is all about. So I'll discuss some of the concepts, like how it works. Then it makes sense. So the official definition is it's an open platform to connect, manage, and secure microservices. That gives you some context. But let's understand how it works, like under the hood. So without Istio, if a service A is calling service B, how does it call? If you want to get metrics, all the features that we discussed, if you want to get all those features, you need to have a library that is embedded into your application. So your library will call the other library. That's how you get it, right? But it is very much tied to your application. And then in the Istio-based method, your library goes out of that and then stays out of your application, but runs as a sidecar container for your application. Okay, so your app container is there, and you have a sidecar container which does all of these things for you. That sidecar container is nothing but a proxy. It can be a Nginx proxy. It can be a let's say HA proxy, which is more complex to implement for all of this. But think of it as a proxy running just side by your application, but this proxy is dedicated for your application. Okay, whenever your application wants to communicate with any other external system, it has to go through that proxy only. Only then that proxy will be able to control how this application is communicating, right? And also get all the metrics details, like how many times this request is failing. If the request failed, I can also retry. So that proxy that you see here on the middle layer will do all the job for you. And that proxy is platform agnostic, like it may be language agnostic also. It works for Java, Node.js, any language you choose. And also platform agnostic, as in it works on Kubernetes. Sometimes in the future, it might work for VMs also. So that's how you achieve that all the features that you have listed here without actually writing a code. Okay. So let's get into the Istio part of it. So when I said Istio does this by the sidecar proxy, that sidecar proxy in Istio is basically using Envoy. Envoy is a proxy developed by Lyft. It's a lightweight proxy, C++ proxy that sits right beside your application. Okay, so let me show you that project here. It has a very good definition of how it works. Maybe I don't have it here, but okay, I'm going to explain it. That's fine. So you have a microservice application. It's a book info application. Think of it as a website which gives you information about a book. Maybe it is reviews or details like who is the author and everything. Okay. So when I hit the product page, like if I want to see a book information, it makes a couple of calls. So we need to understand all these differences between these microservices. Only then I'll be able to show like what really microservice is, because I'm using some of these concepts here. So product page, the book information page is calling reviews microservice, which has 3 versions of it. One version doesn't show anything, like it has no stars in it. The second version shows a black star, and the third version shows a red stars. Okay, very silly features, but just to understand. And then there is a Ruby service which gives you details about the book. And then there is a ratings service which is written in Node.js that gives ratings like information for this book. Okay, so typical microservice example. What you want to do is from a just by using some simple YML files. Okay, in the previous case we have used a Jenkins pipeline file to be able to control a complex pipeline. In the same way, we want to use the same YML file format to be able to control how this request flows and also get visibility into what is going on inside your application, inside your microservices. So when this calls this one, I want to control like only go to V1, don't introduce the other two. Okay, or maybe only for a user called Jason, or maybe for a user who is residing in US East, show the second version. Okay, these are very complex canary deployment strategies that you need once you get onto the day-to operations of your microservices. So in this case, we will do all these things just by simple YAML files. Okay, and also we will see things like when this service is calling the other service, how much time it is taking on an average. Okay, for a over a period of time, how much average time is it taking? Okay, for each call. And then also we will do things like this review service. We're gonna retry rating service 3 times before it gives up. Okay, all those things. And then one more thing is, let's say this rating service is an external rating service, maybe Yelp or some other service is giving ratings for this particular thing, which is costly. You don't want to get over a limit. Let's say I only allow 1 request per second. Beyond that, it will say out of capacity. Okay, and then if you want to achieve this in a normal way, you have to do some coding inside your application, right? But using Istio with a simple YAML specification, we are going to achieve that. Okay, so that's the context behind it. But let's go and take a look on the actual implementation. So, any questions on the Istio side before we jump into the demo? Okay. So I'm going to set up Istio because this is a brand new cluster. I haven't done anything. I'm going to set up. So the setup, if you're familiar with like OpenShift syntax, this might be useful. Otherwise, it's just like bunch of commands. Okay. It says it needs to give some kind of privileges to the running containers because the proxy is getting like a sidecar container for your application. So it needs some kind of exceptions in OpenShift. So that's why. And installation is pretty simple. You just say OC apply, install, and then the YML file. Your entire Istio control plane will be available. Okay. So give it a couple of seconds. Although you see a lot of objects here, these are just specifications. These are not really deployments. Only few of them are deployments. And then you need some kind of add-ons like Prometheus to collect the metrics. So when one service calls the other service, you want to collect all those metrics, right? So that metrics are stored inside the Prometheus. So Prometheus does that job. And then to show that metrics, you need to have some kind of UI, which we are using. In this case, we are using Grafana to show them. And then there is a small utility called service graph, which really shows like how your requests are going between applications. And that is built on the fly, right? So you will really know like how your applications are getting called. So this is our application, as you can see. The same thing I've shown. I'm using OC apply, and then this bookinfo.yml has all the specifications to deploy all these services like detail service, rating service, product page, everything will be deployed just by applying this YML file. Okay. Now if I go to my namespace, okay, sorry. I should have gone to my project. Okay, I really want to do it in this namespace, so just because examples are, my demo script is built for that. Sorry about that. So I'm just going to do it manually. I just apply this, and then everything should get deployed in this cluster. Come on. I can see all these are getting deployed. The only change that you see is you have a actual container, which is the application container. There is a sidecar container, which is a proxy running in the same pod. The Kubernetes architecture is pretty friendly with this type of deployment because you can run multiple containers per pod inside Kubernetes, unlike the typical Docker container. Okay, so now it is getting deployed. Meanwhile, what we're going to do is just create a route for this product page. Once it is ready, we are going to hit it. Okay. So give it a couple of seconds for them to get created. Meanwhile, what I'm going to do is expose my metrics and then the Prometheus endpoints so that you can go and see the UI. So I'm just exposing Grafana, which is the metrics thing. It's coming up still. Give it more seconds. And the service graph, which is a small utility which shows how your applications are getting called. If you hit this now, you should see it as empty. Yeah, so you can see nothing is there because we did not go and we did not hit that endpoints, right? So there is the microservices, even though they got deployed, they did not call each other. So this is empty now. Once we hit the endpoint, you should be able to see it. It automatically builds it. So let me go to my project, and then they're still coming up. It takes a couple of seconds because it needs to download the image and then deploy. Okay, it came up. Few more seconds. You can see the logs inside this. I think it's pretty much visible here, very transparent. You have to do a lot of CLI commands if you want to see these logs inside Kubernetes or typical Docker deployment. If you want. Okay, let me see if I can hit this. It's not up yet. Maybe this is written in Java, so not Node.js. I hit this for just a couple of seconds. First deployment is a bit delayed. Still booting up. Can give it a few more seconds. But you can see the whole application stack got deployed here. We have 3 reviews and then 1 rating service and then 1 product page service. Okay. Come on. Okay, this application is open now. So you can see we hit the product page main page. This did not call the services yet. Once we hit the normal user or this links, then it will go and call the other services. But let's see the service graph, what it built. So you can see from an external system, we call the product page. So it understood based on the sidecar proxy metrics, and then it built that chart for us. Now, if I hit the actual product book information page, I hit the book information page. I went to reviews, the version 1 of reviews, which doesn't have any stars. Now, if I reload this, you can see my reviews version 1 is called. Okay, so the whole graph is built whenever applications call each other. Okay, and then this is the free information. You have not spent a like minute to get all this information, right? Like at least in the coding perspective, you did not code anything. You are getting this information for free. And then if I hit this, it might go to a different version of reviews, which is a reviews version 2, which has black stars. If I hit it again, it might go to version 3, which has red stars. Okay. because as of now, we don't have any rules that it should always go to version 1 or version 2. Because we have 3 instances, it is just doing round robin between these 3 services. Okay, is that clear? Now, if I do a refresh here, you can see it is calling 3 services. So product page is calling reviews, and then reviews is calling rating service. And then the other one is detail service, just like the architecture. Okay. Now, once we have this, so in this particular version, my metrics is not working, but trust me, it works on a later. This is not a stable release. We're still working on a stable release. But what you will see here is you will have the all the services listed here, and then you will also see the number of failed requests or succeeded requests. Like let's say global request volume, you will see how many number of requests succeeded, how many number of requested failed with a code which is 400 something, like non 500 code, and also 400 codes. Like all these metrics you will see it. Okay, in this installation it is not working, but they're soon going to release a 0.2.6 release, which is again very alpha kind of thing, but this has some issues. Okay, so I'm not able to show that. I have a video which is where it is working on my YouTube channel. You can see that, but in this it doesn't work. So in this deployment, it is doing a round robin between these 3 microservice instances, right? That's what we have. But what I want to do is control how these requests goes through this. So I want to always route my request to version 1. So how do I do that? Let's take a look. So I said we need to use some simple YML files. I'm doing some like exposing those things. You don't need to worry. You can skip them. It's metrics as well. It's not needed. Now comes the request routing part. So I want to route only to version 1. How do I do that? Some cleanup for always I do that so that my scripts are always working. So I say I will apply a rule which says route to only version 1. Okay, all the microservices have version numbers on them. So when I apply this rule, it should always route to version 1 of the instance. Okay, how does that rule look like? It looks like something like this. If the destination is reviews and the namespace is my project, which I already have, with the precedence of 1, always route to version 1. Okay, is that clear or confusing? So if the request goes to reviews, always route to version 1. That's the whole point. Okay, when you apply this YML file, if I go and refresh this again, it will always go to version 1. Even if I hit many times, you can see that it will always go to version 1. Okay, so I can control how the request flows between microservices just by a simple YML file. Now the complex part. Let's say for a user called Jason, I want to route to version 2, but for all others, it will go to version 1. Okay, this is needed when you want to introduce new features without breaking the existing system. Okay, so maybe for testing in production, not in QA. QA you may be able to do it, but there are requirements where you want to test it in production before it goes to all the users. So how does this rule look like? This rule is a flexible rule. It looks at the cookie value, and then the user has a if the cookie has a key value pair called user equal to JSON, always route to version 2. Okay, as simple as that. This can be cookie, or this can be your own implementation, like east west or whatever complex business logic that you want to implement. Okay, and then when I say this, for all other users, it should go to version 1, which is still it is going to version 1. But when I log in as a user called Jason, it is going to version 2. You can see it here. Okay, even if I refresh many times, it will always go to version 2. If I go back to normal user, it goes to version 1. Okay, so you can have a precedence. You can have rules that you can for very complex canary deployments as well. Okay.
That's open
This is Istio specific feature.
Okay.
Yeah, but OpenShift also has a like feature which can split the traffic between, like, let's say 10%, 90% very easily. But as of now, it doesn't know based on like some header values. It cannot do. Yeah, that's the Istio part. So once we are happy with let's say version 1 or version 3, we want to route all the traffic uh, between version 1 and version 3, or maybe everything to version 3. So this is everything to version 3. Let's take a look. The rule looks something like this. Oh, sorry, it's a split between version 1 and version 3. So if the destination is reviews, um, just split the traffic between version 1 and version 2 50-50%. Okay, clear, right? That's the only YML specification. But for user JSON, we have a precedence 2. That means when the user JSON goes in, it will go override this request and go with the other rule. And now if I hit this, it will not be like very consistent, but you can see version 1 and then the red version. So with stars, red stars and no stars. That's the only thing that you see. But you'll not see black stars. That's a version 2. Okay, because you split the traffic. And then now everything to version 3. How does it look like? It's pretty simple. Everything to version 3. When you say weight equal to 100, everything goes to version 3. Okay. So that's the whole point on the routing rule side. But some of the things like fault injection. So you want to see when a service A calls B and then B calls C, if something goes wrong between B and C, how does it impact with A, right? So very complex scenarios, you can simulate them just by simple YML files. So what in this case, what we want to see is inject some delay into one of the microservice and see how it is affecting the other microservices. So I'm going to delete all the existing rules. So we start from scratch. And then I have a rule which says route everything to version 1. That's the standard rule applicable to everyone. But for a user JSON, I want to route only to version 2. Okay. How does it look like? We have seen it already. So for a user, always version 2. So this will not affect everyone. This will affect only user JSON. That's the point you want to make. I want to make. So for a user JSON, I want to add a delay on rating service. So product page is calling reviews and reviews is calling ratings. And then we are adding a delay on rating service. We are adding a delay of 7 seconds for 100% of traffic. You can all split the traffic there. Okay. So for user JSON, add a 7-second delay on rating service. Then if you log in as, so if for normal users, for all other users, it will be same. Like they will not be affected. But if I log in as a user called JSON, you can see it is taking a long time to load that because we introduced that delay of 7 seconds. Okay. Now you can see it impacted the end user. So if our rating service breaks, everything on the front screen will be broken, right? Like you won't see that results there. So we understood that in the testing stage, even before it goes to production. Okay. So you can add maybe a retry mechanism on your rating to reviews to rating service, so that to mitigate this problem temporarily, and then you can look into the other performance specifications. But I think you get the point, right? So sometimes you want to have timeouts between microservices. So just try for some time. If it doesn't give, just do a timeout. Okay. So how? Let's take a look at that. First, I'm deleting all the rules and then applying like only it should go to version 1. And then what I want to do here is I want to apply a timeout on review service only on version 2, just for testing. Give me 1 second. So that shows a delay of 5 seconds. So first we want to add a delay of 5 seconds on the rating service, which is almost the end service where reviews is calling ratings. So I want to add a delay on this rating service. So which is nothing but, in this case, I'm adding a delay here on the ratings and then adding a timeout on this review service. Okay. So I'm adding a timeout. You can see all these are YML specifications. You're not doing any code changes and nothing of that sort. So you just say HTTP request timeout, and it's a simple timeout implementation which says, although the rating service has a delay of 5 seconds, if the reviews to request service is not happening in 2 seconds, just give a timeout and then throw a appropriate message to user. Okay. So this is useful in many cases. Now let me take a look here. So this is for all the users. So let me log out. I think I ran over time. All right, so we're gonna wind up, but there are a lot of other features as well for microservice management. So you can see 1, 2, 3. Within 2 to 3 seconds, it will time out. It will not wait for 5 seconds, right? Although ratings has a 5-second delay, it is timing out in 2 to 3 seconds timeout. Okay, so that's the whole point. The final one we have is rate limiting. So like I said, if this rating service is a paid service and then you want to have some limit on that limit embedded on that, how do you do that? So yeah, this is a quota thing. What I'm saying here is, on rating service, if the call is from review service, which is of version 2, if I'm making a call from this service to the rating service, put this limit, right? So you can only have maximum of 1 request per second, or maybe like 1,000 requests per second. More than that, just do a limiting there. Okay. So I mentioned that, and then I say this is another handler that you need to put in. Don't worry about it. You can have different adapters for doing this. So I'm using a memory adapter. You can also have Redis adapter. So that's the specification there. Now you can see I'm from reviews version 2. I'm calling rating service in this case. So from reviews version 2, I'm calling rating service. So you can see every other request, I'm making request every half second. Okay. So you can see one of the requests succeeds and the other request fails, because I'm making, there is a 1 second limit on the rating service. I'm making it for every half second. So that is why one request is failing and the other request is passing. Okay. So all this you are doing without actually writing any code. So there are a bunch of other features as well. We will not be able to do it in this timeline, but I'm doing like few more use cases around this in YouTube channel, which is here, user/Debian master 2. There are a bunch of videos on that, and then I'm going to add few more as well. So if you're interested in it, please take a look. And one more important thing is Istio is in alpha. It's nowhere near to production yet. This is a new tool that is coming out, but very interesting one. Okay. Google, IBM, Lyft, and then Red Hat is also participating or interested in. I don't know the exact, but I mean, I don't know the direction, but as far as I know, Red Hat is also very much interested in. Lyft, yeah, the Reich. Yeah. Yep. Yes. You can have a different strategy as well. I did not cover in this. Like you can have round robin or least connection, a very complex routing you can have. Right. I'm going to end this stream.